Okay, so we're going to take a look at a relation, and we're going to write the inverse of the relation. Now, we don't know if this is actually a function. I mean, you could, I've taken this relation, and it's, let's see, it looks like 5 ordered pairs, and I put them in mapping notation, which you can see that the arrows represent the ordered pairs. So an ordered pair, -2, 2 is plotted here, 1, 3 is plotted here, and so on. And one way I could tell that it's a function is if I look and see that none of the points of the graph lie on the same vertical line. That's called the vertical line test, and you can see they don't. The other way I can tell is see how there's just one arrow coming out of each input into the output, in other words, into the range. So I can see that there's no x value that has more than one output. So each output is unique for each input. And so I plotted the points, and I also plotted the line y equals x, because we talked about how if these points are reflections of each other over this line, then they would be considered to be inverses. So to write the inverse, I just simply, if they're ordered pairs like this, I just simply reverse them, so that my domain now would be what was the original range, so they would be 2, 3, 6. Now when you list them, and this was kind of an error to do that here, this really should have been simply just 1, 6 listed here. We don't usually list them twice in this notation, but I was really trying to emphasize the ordered pair aspect of it. So what would really be happening is both of these would be going into the 6 here. So we list the 6 one time and the 8, and that's the domain, and then now the range, which is -2, 1, 2, 5, 6, the original domain. And now I'm going to map these together. So now 2 is going to be mapped to -2. 3 is going to be mapped to 1 instead. 6 is going to be mapped to both 2 and to 5. So right there, here's how we can tell that this relation is not a function. So the inverse is not a function. And that's because you have 2 coordinates, 2 inputs of 6 that have 2 different outputs. You have 6, 2, and you have 6, 5. Okay, so this is not a function. And then 8 is mapped onto 6 when we go backwards, when we go to the inverse. So now when I plot these new points, I'm going to plot them in a color. So 2, -2 would be over 2 and down 2. See how this point right here is the reflection of that point right there? 3, 1, over 3 and up 1. So this point right here is the reflection of that one. 6, 2, so over 6 and up 2, that's the reflection of that one. And 6, 5, over 6 and up 5. See, 2, 3, 4, 5, that's the reflection of that one. And see how they're on the same vertical line, that's why that's not a function. And then 8, 6, 1, 2, 3, 4, 5, 6, and you can see that these points are reflections over that line. It even helps sometimes if you connect these, I connect them if they're just ordered pairs with a dashed line to not mistake that it's continuous. But if you did that, you would see that these points are reflections of each other over that line y equals x. So they're inverses, and even though this is not a function, it is still the inverse of this relation or this function.